Should I switch on the camera?
Yes. Very nice.
Yeah, good afternoon to every students. We are third and final live session of this course, CBS VLSI design. So I should come and
Yes.
I hope you are enjoying the course. We are almost in the end of the course now, and end time is coming. So if you have any questions, anything related to this course, I'll be happy to answer or clarify any doubt you have. So I am seeing in the YouTube channel, many of the students are quite active, not the our discussion forum, getting quite few questions and many interesting questions. So that I really appreciate. Specifically, few questions are very interesting, very in depth. So it shows that many of you are following the course very seriously, which is really pleasing for me as well. Okay, so in this forum, I want to take questions from you, and we'll discuss. If you have any doubts, you feel free to just post the questions here. We'll discuss. I think one questions we already have. So the questions from Saurabh is dynamic or static TSPC flip-flop, which one should be used? Should be considered for designing a high-speed application. I don't know the answer, honestly, because this is not something related to this course that I'm teaching. This is much more on design side. So honestly, I have no answer to this question. So any other questions you have? So please feel free to post your questions. So at the last part of the course, what I covered usually how you can generate a secure design through HLS, where you can actually protect the RTL from IP piracy or overbuilding. That part we covered, and then the functional verifications, formal verification of HLS. How can you formally check whether the RTL that is generated by the HLS tool is functionally equivalent to the input C code? Similarly, I also take certain tests as case studies, and I have shown that how the quality of the generated RTL can be improved with the correct version of the C code. Right? It's this is very well known that if you from any C code you cannot generate an efficient hardware, right? So you need to write hardware friendly C code. So I have taken certain examples and show how small changes in the C can make a very efficient hardware, right? So so those things I have covered, and also I have covered the after the HLS you have logic synthesis and physical synthesis, right? So the complete EDA flow, the VLSI design flow, that also I have covered. But since the primary goal is from C-based VLSI design, so the majority of the course was invested on this how to generate hardware out of C code, and briefly covered the logic synthesis and physics synthesis part. And I have seen there are quite few courses available in NPTEL platform as well on logic synthesis and physical synthesis. So if you are interested to learn those in detail, like logic synthesis, how this logic optimization happens, technology mapping happens, how this FPGA mapping happens in detail, or physical synthesis like placement routing, floor planning, partitioning, all those in algorithms in detail, you should go through those NPTEL courses. Okay. And the final suggestion is you won't able to learn the technology without using the tool or the software. So I'll strongly suggest who are looking for uh, 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 to use these tools, in the sense you can take any tool, maybe VTS from Viva, this Xilinx, or any other tools, HLS tool which is available to you, and try to generate hardware and see how the performance varying with different optimizations. Okay, so that is kind of must. Okay, so few more questions. And Nishant has one question is regarding securing the IP, adding additional gates would be affect the speed of the system on every stage. Yeah, it's a good question, Nishant. So yeah, you are right. So when you lock a design, right? So specifically, if you see in the C level, how we are locking, we effectively lock with a dummy operations, right? Or say we lock a constant, or we lock the condition. So once you lock the constant, it does not affect much because it's still the same width of the data, right? Only a constant replaced by a variable. So that does not give much impact on the hardware. If similarly the conditional optimizations, because conditional locking, because conditional locking is just a one extra bit you just do XOR, right? Um, uh, uh, the kind of just the cost of one XOR operation, which is very less in hardware. So again, this conditional locking also does not have much impact. But if you see this operation locking, where we basically use a dummy operation, right? So you have basically A equal to B plus C. You just hide this operation. So you say if K, then you do A plus B, B plus C, or B minus C, right? So that means your K is 1. And if K is 0, then you do some dummy operation B minus C or B plus C, the actual operation, right? So now you are effectively adding some dummy operations, and this dummy operation has to be scheduled. So you need to, well, you probably need more time. So latency might increase of the design, because if you say log 20 design, so now you have 20 extra operation to be scheduled. So which may not be possible to done in the time number of clock, which can be the original behavior can be locked, right? So that's something impacts, right? And similarly, once you have the dummy operations, you have to again map into the register, sorry, this to the function unit, right? So that operation mapping, right? That just like register mapping, we also have the operation map to function unit FUs, right? So we may need more FUs. So to summarize, effectively, once you lock the operations with additional operations or dummy operations, what will happen effectively is it will increase the latency. It might increase the latency of the design, as well as it will increase the resource or the area, right? Overall area. And if in some cases it might also impact the critical path. Chance is there, but the chance is small, because you are effectively creating a completely new data path. You are not modifying the existing data path. But there is a chance that there are some marks getting added, right, because of this dummy operations. So that might also impact the critical path. So, in summary, among all these locking thing that I have talked in the class, operation locking has the maximum overhead. Okay, so so you should avoid operation locking, right? Instead, you try to lock the constant or lock the conditions, and only very few operations, right? Then your overall impact will be less. That's the kind of my suggestions. But yes, you cannot get this lock design without some overhead. You will have some overhead, but your objective should be to minimize the overhead. That's the kind of idea. Saurav has again question. Please suggest few ways to perform critical circuit path analysis of digital circuit transistor level, are there any tool to find critical path? So yeah, so it's very simple, right? It doesn't matter in which level you do this analysis. Effectively, you have to identify the combinational path, right? So from two between two registers, from one input to the registers, or from register to the output, right? So there are three kind of path: input to register to registers, and register to output, right? So these are all kind of combinational path. Among all the paths, whatever has the maximum delay, computation time, that is the critical path, right? And if you use any tool, they gives it, right? So there is no any tool, it will say this is the critical path. And how it basically does is basically simple DFS, depth first search. You start from a registers, you do a backward DFS, and whenever you reach to the input or register, you will just keep adding um, uh, the delay or the computation time of the nodes in the path. That will give you the critical path. So I don't think that's something. If you are familiar with any synthesis tool, it will give it. Even if you see the synopsis design and design compilers and all, they always print all the path that has the highest delay, right, or which are the critical paths, right? So I think if you use any commercial synthesis tool, they always report the critical paths. You can write your own as well, right? If you have a gate level design or transistor level design, as I mentioned, you can just write a modified version of the DFS that can actually give you the longest path, but you need to know the exact value of this delay, because that is very important. It depends on what is your target platform, right? So if you go for ASIC, the delay will be different. If you go for a FPGA, the delay will be different. And also the different library has a different delay, right? It depends on which library you're also going to use in ASIC. So these numbers are very sensitive to the target platform. So usually whenever you select, so this critical path makes sense once you select a technology library in the ASIC flow, right? If you do a FPGA synthesis, when you do the PNR, right? So placement and routing, then only these numbers are real, because then the tool will select the particular or the target platform, and these tools have those data internally. They knows the kind of the delay or the computation time of each component of the library that they're using. So as a result, these kind of numbers are quite accurate when you go the lower level, right? Okay, so one more question Nishant have. Follow-up questions, would it be any impact on the scheduling of operation as well? Yes, yeah, that is I have already mentioned, right? So let me try to explain this. So is the skin visible? Skin is visible, right? So you have to share the skin. Okay, so I'll do that. Yeah, so just to explain why this may change the scheduling, it will change the scheduling. I'll tell you, explain. So suppose you have a behavior which is like this: A equal to B plus C, and then say output equal to A minus D. Right? A two-line code, right? So, and suppose you have only one adder, right? One adder in the sense it will can do the addition or subtraction, right? ALU. So then initially your schedule will be like this, right? So suppose this is operation 1 and then this is 2. So it is basically in 2 clock you can schedule it, right? So suppose here the plus will be scheduled, here the minus will be scheduled, because there is an operation dependency, right? So out will come here, right? So B and C will be here, and this is the schedule, right? So now you think about that I lock both the operation. Okay, so I lock like this: A equal to K1, then B plus C or B minus C, right? And then you do O equal to K2, then you do A minus D or A plus D, right? So here your correct key value is K1 equal to 1 and K2 equal to 0. So the now you see that there are 4 operations to be scheduled, right? So and you have only one adder. Say I'm doing say resource constant scheduling. So you obviously your schedule will be like this, right? So you will do B plus C here, then B minus C here. Again, the same B and C is coming here, and then your K will decide, right? So you can actually decide. Uh, so you can actually have as a merge operation is basically a mux, which is uh, in the high level. I can just write like a node like merge node, uh, which will be mux at the hardware, right? Similarly, here I'll do A minus D, right? So I'll do A and A minus D here because I have only one header, I'm assuming, right? And then in the next block, I'll do A plus D, right? So A minus D or A plus D. So I'll do A and D, and then there'll be a merge here, right? Merge will be basically a mux. In fact, merge can be there itself because it is basically a mux, right? So it depends on your design. So you can just, it's kind of a convention how we'll represent. So you can see here that your initial design was 2 cycle, now you have a 4 cycle, right? So you have 4 cycle, right? So obviously, because if you have, uh, sorry, not this one, so this will come here. And this A is basically this, right? So this is your A. Okay, and this merge, okay, let me just correct it properly. So this merge can have here, right? So this is coming here, and this is your A. This is going to, so this A is going to, yeah, this is your A basically, right? And same A is going to this plus. Right, so you understand, I think. So yes, it will impact the scheduling because you have more options to schedule. I hope it is clear. Um, any other questions? Okay, so I think there is no further questions, so I'll wait for another couple of minutes. And if there is no further questions, we'll wind up. I'll wish all the best for your final exam. Hope this course was useful to you, and please feel free to reach out to me in offline mode as well, right? So if you have any further questions related to this course and also feel free to reach out to me. Okay, I think there is one option for internship as well. Who will perform well in this course. So I'll be happy to host any intern, but there is an online internship I offer. Right? If you want to do internship, you have to come here in IIT Guwahati. So one more question Nishant has. It is clear now. Sir, I am curious about that for EG when we introduce XOR gate in a module, can we add it anywhere in the circuit? Yes, so yeah, so I think yeah, you are going more detail into this. So in the course, I just talked about in very high level, right? But we do work on this kind of problems. It's important questions that if say you want to create a circuit with say 100 keys, okay, and there are many operations are there in the behavior. There are many constants. There are many conditions. So there are many ways you can lock. Okay, so and if you remember that I also talked about attack, right? SAT attack on that or SMT attack on this kind of behavior. So what is important is that if you try to lock your design, uh, there are hundreds of ways you can lock it with a fixed number of keys. And it is interesting to note that not that the number of keys is the only factor, right? So it may be that, I mean, we have seen cases here when we do attack on designs. Even say, take an example of 100 keys, which can be broken in few seconds, and then maybe the same design with locked with 100 keys, but in different location that cannot be broken at all by SAT attack. SAT attack will fail. So the number of keys is not the only factor. The important is that where to lock, right? So there are a lot of analysis you can do. You can identify how a particular locking will make your the SAT attack difficult. There are a lot of theory involved, right, which cannot be discussed in this small forum. But the idea here is that you need to understand what are the cases where this attack tool, like SAT attack tool, is not efficient. Okay, I'll give you a very small example in the sense that if you make your expression non-linear, okay, non-linear, there's a multiplication of variables. The SMT tools find it difficult to break such things, right? So effective idea is that if you lock such a way that your non-linearity increase in your locked behavior, the SAT attack will find it difficult to break. Okay, so to cut the long story short, it's basically you need to understand how this attack works. Based on that, you need to identify the good locations in the design. Where if you lock, uh, it will make more resilient design. Okay, so that's the point. So it's not random. You should not add lock randomly. You need to have some analysis, some parameter based on which you should lock so that your overall resilience is high. Okay. When you understand that if you increase the number of keys, obviously there is overhead. I have explained with example, right? So so obviously, your objective is not that you increase the number of keys as much as possible, right? Uh, but it will be interesting. How can you make a strong or robust lock design with minimum number of keys? Right? That's the kind of research problem that our team is working. Okay, so one more follow-up question from Saurabh: how to apply ML techniques in design level in order to enhance the performance? So you need to specify what performance you mean, right? So, um, I mean, you have to characterize or define your performance. And performance can be anything, right? So if you can clarify what performance you're talking about, I can explain. Yeah. So I think yeah. So let's wait for sort of input what performance he's talking about. Uh, in the meantime, there is Manu has a question that kindly suggest some good project by doing. I can feel confident on HLS design. Yeah, it's a good questions. So I will suggest you take example of image processing applications because it involves a lot of data, a lot of loops, right? So you'll see a lot of benefits when you apply loop pipelining, loop unrolling. So you'll see a lot of differences, right? If you apply complete unroll, you see your overall area will blow up, right? If you take a matrix multiplication, if you unroll everything, it will blow up your FPGA target. If you have a small DSP, it will say it will not fit in a DSP as well. Okay. If you pipeline, you see that your area will increase a little bit, but your performance or the number of latency reduce drastically, right? So there are three kind of things, right? If you do a iterative iteration, so your area will be minimum, latency will be maximum because it will take n cycle, right? Now, if you do this complete unroll, your area will be maximum and latency will be minimum. Okay, and if you do pipeline, it depends on number of states, so it will need it will increase your area a little bit, but because pipeline all stages are working in parallel, your latency will be reduced, right? My suggestion would be you take certain image processing application. There are so many. You just copy paste the code from internet, and then you try to apply all these optimizations, and then you see, just like the Mars sort example that I've taken in the course, right? You see what is the memory access pattern. Can you rewrite the code to reduce the memory access pattern, right? So those are the kind of good thing which you should take into consideration. Okay, this is one direction. The other direction I'll suggest is again ML application. Say suppose you train certain CNN model or some ANN model, okay, and you got a trained model which is a Keras, right? So if you use VTs and all, I think there is an ML model which can take directly these things, but I suggest there are certain tool like Keras to C. You'll get it into GitHub that will convert your this ML model into C code, right? And then you use this C code to synthesize. Since this ML application has again very nested loop, right? Convolution is a nested loops. Any basically ML application is effectively a nested loop because you are moving a window in the uh, in the uh, uh, so these are all nested loops, and again you try to generate a hardware which is basically effectively doing this your training testing thing in hardware, right? It's kind of a hardware acceleration of the ML models, right? So this is something is a very active research area, I would say, and people are trying various way. Particularly if you take any application, if you do it in HLS, you'll realize that you have to do a lot of things to improve the performance. You have to do this memory access reduction. You have to rewrite the loops such that your this locality of reference increase, right? That will give you very ample opportunity uh, uh, to learn HLS. Okay, so my suggestion is basically image processing and ML applications. That will be the best thing if you do HLS on that. So Saurabh written circuit performance. I can see the performance is basically what is performance? If you ask me performance, can be the latency, it can be the clock speed, it can be the power, right? You want to reduce power, if you want to reduce area, everything is performance. I want to make a very compact design. So unless if your question is vague, answer will be vague, right? You need to write the questions precisely. So, but if I give you a very generic answer to your question is that, yeah, ML is getting a lot of use in EDA. So basically, if you say this, I mean, all this problem, right? Placement, partitioning, your this uh, routing, any kind of all these steps that are being performed in the synthesis flow, they are very complex process, right? So nowadays I'm seeing a lot of work where people use ML to predict the right optimization to be taken for a design. So the idea is that in this tool there are hundreds of optimizations, right? So which optimization to be used in which flow, in which order, that's the difficult questions, and tools use heuristic to decide those. So I have seen many work nowadays which try to help this area to in ML, right? So you try to place millions of transistors in a particular area. So what will be your best placement such that your overall routing wire length is reduced, right? So consider this problem. So you can actually use ML because maybe that so far your tool has used 100 have synthesized 100 of design. So whatever the decision this tool is taking, if you just generate that data, right? For this particular design, if I apply this optimization, I'm getting this is the my wire length, right? If I apply this optimization, I'm getting this. So if I just keep generating all this data, now I can train a particular ANN or CNN model to understand this, right? So under which context which optimization will give you better performance, right? And then when you give, so this is the training happens, right? So next time when you try to synthesize a new design, the optimization you should do. This is the set of optimization you should do. As a result, you will get a best design in terms of say wire length. When I'm taking a consideration of wire length. You can just change the parameter to power, change the parameter to clock speed, right? So So you just can generate all this data from the synthesis backend, and you can actually train ML, and then in future you try to use ML to predict the correct optimization to be applied uh, on uh, this next design, right? And same things happen here. I mean, in HLS also you can apply ML, right? So uh, as I mentioned that even I just talking to giving Manu's answer that you can which optimization to use, which sequence and all those things, right? You do a very thorough experiment with few designs and you keep all this data and then you train your ML model. Next time ML will say if for this design you applies this optimization, that will be better, right? So you can actually, this is design space exploration in HLS, and that can be done with ML, right? It's a very standard, it's a good work actually, right? I don't think there is much work on that. In some of you can take that project as well. Okay. Sayantan has one question. Sayantan sir, which ID or compiler is used for Verilog? See, again, the questions is very vague, very honestly, because which Verilog, right? It's RTL, get level, and all, right? So any compiler nowadays, any commercial compiler can handle all this HDL language like VHDL, VHDL. So if you write your design in RTL, register transfer level in Verilog or VHDL, you call DC that will synthesize your thing to get level, right? Or it will do the PNR. So all these tools are very equipped. It can handle any language. Okay, so I don't see any other questions so far. Is there any other questions? Otherwise, we'll wind up in a couple of minutes. Momo has one question. Is there any tool flow related class? No, because in online mode, what my personal experience is, this does not help, right? So, and these tools are pretty simple, right? So you can just download any tool it is and just see the user manual and run it. So there is no difficulty in running. And there are a lot of examples given in that user manual. So I don't think it will be very difficult to use HLS tool. At least other tools like PNR and all, those are a bit complex, but HLS is pretty simple. So I have not put any class for tool flow. Saurav has one question. What is the best tool for RTL to netlist verification in VLSI? There are many tools like Jasper Gold if you try to go for formal verification from Cadence. If you want to do simulation, there are VCS from Synopsys, simulation-based verification VCS, then model sim from Mentor. These are very quite good tool. Formality, again, there is a formal verification tool. So these are all good tools for verification. And it's getting, I mean, they are all widely used and very stable too. Nishant said, regarding my query on SV UVM resource. System Verilog and all. Yeah, so yeah, I mean, you can Google it. So since this course is not related to this, so please do not expect all this uh, these things are like system Verilog, UVM, we are not covering in this course. So, but these are very well known. If you just Google on system Verilog, you'll get a lot of resource. Okay, so it's not very hard to get resource there. Sonam has one question is, what is the technique to find the loopholes in a research paper related to HLS? Your experience. See, if you try to find out loopholes in in papers, they will keep working on incremental projects, right? So I would suggest you think big. I mean, what you can achieve with HLS, right? And you may come up with something completely new out of box. I mean, that is good research. Um, but usually, to answer your question precisely, it's kind of research. If you keep reading papers, keep following papers, you'll identify the trend, what is going on in HLS. And believe me, HLS is very active in research in recent times. People are using it for many things like hardware accelerator design, for ML accelerator, uh, this cryptographic accelerator. So many things people are using it. And it's quite easy to get hardware, right? So that's the best part of it. I mean, people nowadays does not work much on developing a new scheduling technique, but people try to use HLS to achieve something, um, something bigger goal. Okay, so I will suggest you think big. What new thing you can do with HLS? Sonam Sarma, the mainly different type of attacks. Yeah, so you can just think about how can you, I mean, if I give you research problem, I can give you 5 problems here itself. So say the problem like, can you generate a sidechain secure RTL with HLS from C, right? This is one question, problem you can do. Similarly, the timing channel, right? So there are timing channels are there. So can you design a timing channel secure RTL with HLS? There are work that I do and I presented here, like generating a lock design against IP piracy and all IP overbilling, right? So can you develop RTL automatically, and then in this context, as I mentioned for to Nishant question earlier, you can think about how can you do the trade-off between the overhead versus the resiliency, right? How can you make a resilient circuit with minimum number of area overhead? Right? It can be many area overhead, power overhead, latency overhead, whatever your objective function is, right? So I have given you 3 problems here itself. You can solve them. Saurabh has one more question. Is there a way to create timing simulation for the netlist generated from Cadence RC just to verify that timing is satisfied for the library? Uh, uh, I'm not quite sure, very honestly, here, because I don't work on those Cadence tool or that detail level. When I primarily work on HLS, so I don't have answer to your question, honestly. Timing usually, my experience, or so it's like many a time you basically see that some of the paths are critical. They are not able to, you're able to meet uh, the critical path or the target clock, right? So then the usual idea is that you can actually modify your design. So you identify the critical path, and then probably you add a level of register in between. You just add a one level of register there so that you break this. So, or you can do retiming, right? So retiming is, you can enable the retiming in your synthesis tool, and then you mention that you try to do, make sure that your retiming brings certain register into this, right? So effectively, what is your critical path? It's a combinational path which delays more than the target clock, right? So to break this, the simplest way that you have to bring some register and break the critical path. Right? That's the thing that you need to do. I mean, you can do it automatically using the optimization called retiming, which I have covered, I guess, in the course, and or you can do it with on your own, right? If you know your design well, okay. And there are some optimizations are there, like I would say this one is called replication, one is called folding. So this kind of optimizations are there in the tool. So you have to know that what kind of optimization can impact the critical path, right? And then you have to apply them, right? So basically, it's kind of a trial and error. right? You need to know what the optimization can help, and then you apply them. That will help effectively. Subha Kumari. Sir, is there any good IEEE paper on HLS? There are thousands of good IEEE papers. I myself have maybe 10. Okay, so there are quite few papers, but if you are really serious about doing research in HLS, I would suggest you follow the top tier conference and journal. Nowadays, a lot of substandard conference and they don't follow substandard conference and journals. Okay, so if you ask me the good IEEE journals in this domain, like IEEE transaction of CAD for CAD of ICS, then which is called TCAD. There is a TVLSI transaction on VLSI, ACM transaction of design automation, which is today's. There is one good journal called IEEE Design and Test. These are good conference journals. Sorry, these are all journals which publish top tier good work, right? And if you look into the conference in this domain, is DAC, Design Automation Conference, ICCAD, International Conference on CAD, Computer Aided Design, DATE, Design Automation in Test in Europe. These three, maybe VLSI, which happen in India, these are good venue, right? So you should look into papers which publish in this forum, because then you'll get an idea what is the state of the art research. Otherwise, we'll see some junk work that won't help. Okay. Gaurav has one more question. So I like so many questions are coming. So is the design of high-speed adder still a recent research issue in VLSI, or is it overdated? So if you ask me, there are so many adders, right? Carry look at, carry save. So many adders are there. It's a well-researched area. But what I see nowadays, uh, primarily I would say multiplier, but approximate computing, right? Approximation. So you try to develop a very fast multiplier, but which maybe the result will be say 5% error, right? Since some cases exact value may not be needed, right? You just need a range, right? So suppose you are just predicting whether you need to say apply certain things, right? So some gear or not, right? So you may not need the exact value, but some approximate value which is very close, right? The error should not be very high. Actual result may be 100 if you're getting 99.5, which is okay, or 100.5, which is okay. So so those are called approximate computing, right? So I have seen a lot of work still date which try to develop adder multiplier for approximate computing, right? So that can be an area where you can look into. Sona has one more questions. Okay, no problem. I know the difference between FPG and ASIC. Could you please explain why FPG is reconfigurable while ASIC is not? You know the answer, right? You know the difference. Okay, anyway. So what makes FPGA special in this regard? Yeah, I'll answer your question. In ASIC, you don't have any hardware, right? You develop your hardware, right? So you basically from your scratch, you decide, say if you do HLS, right? You have a C code, then you do RTL, logic synthesis, physical synthesis, then technology mapping, and then you are getting hardware, right? So you are basically making a application specific hardware, right? So there is no, it's a hard thing, right? You cannot change it because you are developing this, right? In FPG, you already have a hardware, right? It's basically if you buy a board, the hardware is already there, right? The specialty here is that this FPG is reconfigurable, right? So what is reconfigurable? I'll explain. So in the sense in ASIC, suppose you want to make two connections, you have to use a wire between these two nodes, right? But in say in FPGA, your interconnections are already there, right? You already have a interconnections. You need to only know which one to use, right? So for example, let me take an example. Let me share the screen and let me explain. Just a second. I hope my screen is visible. So in the FPGA, if you look into, say, suppose you already have the CLBs, right? I'll come to that CLB later. So suppose you already have some component, right? Say I'll take a very small example. There are 4 components, which is where you can map your gates and all, right? And suppose you already have a connection like this. Okay. So suppose this is already there, right? You are not generating. When you synthesize thing to FPGA, you are already say it's already there. I'm taking a very simple example, right? So this is when things are much more complex, but I'm just trying to explain what is happening, right? So if you just think about this way, so now suppose you want to transfer certain value from, say, this is the module A, module B, C, and D. You want to transfer some value, you want to make a connection from C to, say, B, right? So what is happening, what is reconfigured about this? So this wires I have drawn, they are actually they are not basically physically connected. There is a switch between this. Okay, so this is kind of so you can think about there is a switch in every cross. Okay, so let's, so here there is no switch. That means they are not. They're just the 2 different thing in 2 different layer, right? They are not connected. So this wire, this suppose this is wire X, Y, and this is a W and V. So X and V has no connections, right? Because they are just in 2 layers. And I'm trying to give you as idea. So now all this switch has a kind of a bit, right? This is what effectively in FPGA you are effectively generate bit stream. Okay. So what is, so for every switch there is a bit, right? So now we want to make a hard connection from B to C. What I'll do, I'll give a 1 here. So then what will happen? This connection will become fixed, and I want to give so this is coming here, and then it has to go to the other way. So you can actually think about that. You have a switch here as well, right? And then say suppose I want to use X wire, right? So there is a switch here, there is a switch here, and there is a bit signal here. So I'll give this 1 here. So this will become hard, right? And then I'll give this equal to 1. So what is happening? So now you have to make a fixed connection, right? So this like this. So this is kind of configurable in the sense that if you want to make a connection from C to B, you will give this 1 to these 3 bits. Now if you want to give make a connection from A to D, you will give accordingly, right? So you can give this one 1, then you can give this one 1, and then this one, right? So then this is a connection effectively from A to D. So this is the reconfiguration, right? So your connections are there already. You are just basically deciding based on your application which how to make the connections, right? So this is the reconfiguration. So if you make this bit 1, then this connection will happen. For a different design, you make other bit 1, then the different connection will happen. This is the kind of reconfiguration of the connections. Similarly, the box that I've drawn A, B, C, D, those are also reconfigurable, right? So there are this inside that there are CLBs, okay? So which is effectively has a memory, okay? Let's say you have a design which has 2 input and 1 output, right? So suppose you have a AND gate where there are 2 inputs, right? A and B. A output is there. So there are 4 possible values of AB, right? 0, 0, 0, 1, 1, 0, and 1, 1. And for this, your output is 0, 0, 0, and 1, right? This is the AND gate behavior. So if I want to map this AND gate to the CLB, so CLB is basically a ROM, nothing else. What I'll do, I'll make the connection of A and B here, and I know this is AND gate. The behavior is this. So I have 4 locations here. So I'll put 0, 0, 0, 1. So I'm not implementing AND gate there. I'm just storing the behavior of AND gate here, right? And then you see the case now. So in the FPGA, what will happen? You now you'll give the value of AB will come from some input, and you'll get the corresponding output, right? So now this is my CLB, right? This is a 2 input CLB. There can be 3 input, 4 input, 5 input, 6 input CLBs also. But this is reconfigurable. So the same one I can use for AND gate. Now think about I have a OR gate, right? Same AB is coming. So then this is 0, 1, 1, and 1. So what I'll do, I'll just now store instead of 0, 0, 0, 1, I'll just use store 0, 1, 1, 1. Right. So now the same CLB can be used to implement a OR gate. Right. This is the reconfigurability. Right. So there is no AND gate, OR gate, XOR gate in the FPGA board. They have this kind of CLB, which is nothing but a memory. And you basically, based on your design or the size, you identify the input output behavior and you store the value there, right? So then it is the same thing can be implemented to any gate, right? This is the simplest example, but for a bigger design where there are 4 input, you can take an entire circuit, right? You can take an entire design which has many gates, right? You can map the same entire thing, because at the end you have to do what is the input output correlation. You need to know that for ABCD value 00, what is the output of this design? For ABCD value 0001, what is the output of these values? And all these value you have to store in this memory, right? If the CLB has 4 inputs, right? So this way you can identify a subset of the design, a part of the design, and you map into the CLB. So that is what make FPGA reconfigurable, right? You don't need to make your hardware, right? So hardware is already there. You need to know how to use it for your purpose. That is the FPGA synthesis tool does. Okay. I hope it answers Sonam question. Mm, uh, then you have Saurabh, are there any specific algorithm used for dynamic reconfiguration of current FPGA? So this is the FPGA synthesis tool does, right? So once you use any, say Xilinx FPGA, their tool will basically take your design and they, based on your connection, they'll generate this bit stream, right? This bit stream is nothing but this 10 signals and this 10 signal. So this tool does that, right? There are tools. I mean, any synthesis tool, Xilinx ISE does this. If you take Altera, that they have Quartus, that will does this. So for every FPGA, there is a synthesis tool. Otherwise, you cannot use the FPGA board, right? So the synthesis tool does that. Nishant, yes, Nishant has already answered the question. So any FPGA synthesis tool is doing exactly this, right? So they are effectively from C to RTL, RTL to get level to this bit stream generation. Bit stream is nothing but this 10 values, right? Effectively in FPGA, you have to just send this 10 value. For every switch, whether you are sending 0 or 1, that you have to mention. For every CLB, what is the content, 0 and 1. So effectively, you have to just send a series of 10 value to this FPGA board to execute your design in the FPGA. That's all. Okay. Nishant has one question. All the routing and timing consideration will be taken care of. Yeah, you are right, Nishant. Sonam, what is the max time period to receive a response from a good item transaction about this 4 issues in a year? Usually 3 to 4 months. So far, I saw many times I got a response within 3 months. Many times in 2 months. 2 months is a little bit optimistic. Usually in 3 months to 4 months, I usually get a response from VLSI, TCAD, those kind of formal journals. Manu Kumar has one more question. Sir, where I can get any job opportunity in HLS design, being on your experience in RTL design, seeing the recent market scenario. So, see, when this answer, I almost in every live session, I answer this kind of question, answer to this kind of question. So basically, there are 2 job market, right? One is basically the tool developer who develop the HLS tool, right? People like me who develop the HLS tool, we do not. So the algorithm, right, behind this. So we make this tool more smarter, right? So you try to do some introduce some new optimizations, right? So where computer science people come into VLSI design, and there is another domain where you develop hardware, right? So where who will use this tool, right? So there are set of people who is a VLSI design engineer who use these tools, HLS tool, this logic synthesis tool, and other tools to develop design. They know what is the meaning of what optimizations. If they apply this, what will be the impact? So they are very expert of using these tools, right? So it depends on your expertise. If you are from computer science background, then you should look for this automation job, the EDA job. I mean, if you can see the opportunity. For example, I also worked on the HLS tooling industry for a couple of years, then logic synthesis for a couple of years. So I developed the tool, right? The HLS tool and logic synthesis tool. So so it basically, if you have a computer science background, then you should look into industry like say Cadence, Synopsys, Mentor Graphics. These people, mm, uh, this kind of company, they are hiring those this particular engineer who are good in C++ coding, right? They will develop the software. And company like Intel, Samsung, Apple, Nvidia, Qualcomm, they hire more people from this design background. So where they want people who are very expert in using HLS tool, right? And they can design hardware accelerator quickly. Okay, so it depends on your expertise and interest. I hope this answered your questions, Monu. Saurabh, waiting for your upcoming course. I am going to teach digital design with Verilog in the next semester, but that is for basic, very basic course, the core course for BTech second year. So if you're interested, you are always welcome to attend. Yeah. It's not on Verilog, it's digital design with Verilog. So what I'll do is I talk about, I'll take the basic stuff of digital design, but I'll see how we can optimally design those things using Verilog, right? That's something I'll target in that. Okay, thank you. I think we are almost end of the things. Thank you. I like all the questions, your interest. I hope this course is useful for you, and I wish all the best for your future, for your career. Feel free to be in touch with me for any other suggestions, questions, technical help. Thank you.